Alrighty, so here are your notes for Intro to Stoichiometry, and this is the first 2 pages of your Google Doc. Trying to minimize this. All right, so the first part, I give you a picture of how to make a sandwich, right? Each sandwich is to have 2 slices of bread, 3 pieces of lunch meat, and 1 slice of cheese, and this makes 1 sandwich. So I gave you a recipe for making a sandwich here. So according to the recipe above, what is the mole ratio, or the ratio of slices of bread to pieces of lunch meat needed to make 1 sandwich? All right, so we know that we need 2 slices of bread for 3 pieces of lunch meat. So you can write 2 to 3, or you can use the semicolon, or when we talk about ratios in chemistry or even in math, we tend to think of fractions, right? So you can write 2 over 3, 2 slices of bread over 3 pieces of lunch meat. All right, that's the ratio of slices of bread to pieces of lunch meat needed to make 1 sandwich. So if you have 9 pieces of lunch meat, how many slices of bread do you need in order to make the perfect number of sandwiches? Can someone show me their hands? Do the math out so I can see. Anyone? Oh.
What did you say, Miss? 9 pieces of lunch meat.
So how many slices of bread do you need if we have 9 pieces of lunch meat?
6.
6
times 2 over 3.
Mm-hmm.
Yeah.
All right. So when you're given a number, right? So we're starting with 9 pieces of lunch meat, and we want to solve for how many slices of bread. We're just going to simply use the ratio between slices of bread and pieces of lunch meat to solve for how many slices of bread we need, right? So this is a math problem. You do 9 times 2 divided by 3, and you get 6 slices of bread. All right, so moving on. So we're going to apply this to chemical reaction equations now. So for making a sandwich, we use the ratio of ingredients in order to figure out how many of each ingredient we need or how many sandwiches we can make, right? Similarly, we can use the ratios of reactants and products in a chemical equation to determine how much reactant is needed or how much product is produced. This quantitative relationship between reactants and products in a chemical reaction is called stoichiometry. So this unit is called stoichiometry. So to define stoichiometry is the quantitative relationship between reactants and products. Quantitative just means like numerical, right? It means numbers. It's like a numerical relationship between reactants and products. All right, so let's look at the reaction for synthesis of ammonia. If you notice here, I didn't put any coefficients because I want you guys to be able to still balance equations. So the balanced equation here is 1N2 react with 3H2 to produce 2NH3. So we can now refer these coefficients, the numbers that are in the front, right? Coefficients they're called moles. They're moles of reactants and products. So given the chemical equation, we can figure out the ratio between reactants and products. So what is the ratio between nitrogen and hydrogen? It's 1 to 3, right? 1 and 3. The ratio between H2 and NH3 is 3 to 2 because we see a 3 in front of H2 and 2 in front of NH3. So that's 3 to 2. So these ratios are called mole ratios, right? So whenever we deal with chemical reaction equations, the numbers, when we compare the numbers in front of the coefficients, it's going to be called mole ratio. All right, so question. If 6 moles of H2 react in this reaction, how many moles of NH3 is produced? So given our recipe, so we can call this our recipe, just like the sandwich example. We're given 6 moles of H2. So that's the first thing you're going to write down, right? We're given 6 moles of H2. And the question is asking us how many moles of NH3 is produced. So we're going to look at the equation. We're going to go look at our chemical reaction equation to get the mole ratio, right? Because we have to get the mole ratio. So the mole ratio between NH3 and H2 is 2 over 3, right? 2 NH3 and 3 H2. So we multiply 6 times 2 divided by 3 and we get 4 moles of NH3. Right, so 4 moles of NH3. Let's do the next one. If 8 moles of NH3 is produced, how many moles of N2 were reacted or used? So we're given 8 moles, right? We're solving for N2, so that goes on the top over here. 1 N2 over 2 NH3, because those are the two compounds that we're looking at in this problem. To do the math out, it's going to be 8 times 1 divided by 2, and you get 4 moles of N2. All right, 4 moles of N2.
No, hey, when are you gonna put road?
You always cussing somebody out.
I like this.
You and him are always cussing.
Kira, you have a question?
Never mind.
All right, let's save the questions for at the end. All right, so now after this problem, I ask you how many grams of N2 were used in the reaction. So as soon as you see the word grams, you have to think, oh, I have to solve for the molar mass of the compound given. All right, so that's what I did over here. So I got the molar mass of N2 as 28.02 grams per mole. All right, so how many grams were used in this reaction? So we're going to go back to the problem and get the moles of N2, and that's what we're going to start with, right? So moles. How do we convert moles to grams? Do we multiply or divide?
Multiply.
Multiply.
We're going to multiply. So I'm going to put my molar mass on top. The moles cancel out, right? And if you do the math, it's just 112.08 grams of N2.
Wait, I'm confused. Where did you get 4?
All right, so the 4 is from the previous question. So now when you solve for these problems, you're going to have to look at the problem the previous problem to get the moles of whatever you're given. All right, so because I ask you how many grams of N2 were used in this reaction, right? And we solved for the moles of N2 in the previous problem. So we're gonna take that value and multiply by the molar mass, right? So let's do another problem together, okay? I'm gonna go to this next one. All right, so I'm gonna balance the equation first, which is right there. All right, if 4 moles of calcium chloride, CaCl2, so 4 moles, react in this reaction, how many moles of NaCl is produced? So we're given 4 moles. We're gonna always start with the given. We have to figure out the mole ratio between NaCl and CaCl2. And I see it, right? It's 2 over 1, right? 2 NaCl over 1 CaCl2. So I like to write the compound also, the formula for the compound, so I know which compounds are being canceled out, and then we get 8 moles of NaCl. Okay? So this is mole, so we use mole ratio over here. Now, the second problem throws in this question of how many grams of NaCl is produced in the reaction, right? So now, whenever you see the word grams, you have to think molar mass, right? You're gonna calculate the molar mass of NaCl, which is 58.44 grams per mole. Is someone writing on my screen? All right, so 8 moles of NaCl, I'm getting that from the previous question. All right. And then
Hey, we could write on the screen.
I guess so, but I don't like what's happening here. You guys, stop. All right, I will disable that function for next time. All right, so what's next? So we're gonna, now we're given moles, so we're going to multiply by the molar mass and get 467.52 grams of NaCl.